Welcome back. This will be the third and final video on the sixth section of the prerequisites chapter. I want to do another example of adding, or in this case subtracting, fractions, rational expressions. So again, in order to subtract these guys, we need to find the lowest common denominator of both of these fractions here. So what I want to do first is just factor both of these denominators so that we have a good idea of what we're dealing with here. So for the first fraction, we've got x squared minus 10x plus 25. You'll notice that we've got an x squared and a 5 squared, and the middle term is going to be 2 times 5 times x. So this turns out to be x minus 5 quantity squared. And then we will subtract this other term, and we will factor the bottom. Out of the 2x and the 10, I can pull out a 2, and what I'm left with is 2 times x minus 10, or sorry, x minus 5, and from there I can't simplify this anymore. So to find our lowest common denominator, just off to the side, we'll write down all of the factors in the first denominator. So we've got an x minus 5 and a second x minus 5. And then in the second denominator, I have a 2 and an x minus 5. The x minus 5 already shows up, but not the 2. So the lowest common denominator will have 3 factors in it. This first fraction only has 2 of those factors in it. It doesn't have the 2, so I'll need to add that extra factor by multiplying both the top and the bottom of this fraction by 2. Next, I'll subtract, and again, we'll just write this fraction down. I'm going to put this in parentheses just so that it's a little bit clearer what's going on. And again, I have 3 factors. I have 2 of those here. The third one needs to be x minus 5. So again, I'll just multiply the top and the bottom of this fraction by x minus 5. So next, I'm going to put everything over one fraction, so the denominator is just going to be x minus 5 quantity squared times 2. So again, I just have all 3 of those factors listed. I tend to put the numbers in front. The numerator over the first fraction was 2 times x. The numerator over the second fraction is x minus 4 times x minus 5, and I want to subtract that number. So what I'll do is I'll put this in giant parentheses, but this is one number anyway, so we are good to go. Next, we'll need to start simplifying here. This second term, I can FOIL this out, and we can look at what this equals. So first terms, x times x. Outside terms, x times negative 5x. Inside terms, negative 4x. Last terms, 20. 2 times x minus 5 squared. Okay, carrying on. Got 2x, and now I'm going to distribute this negative sign to every single one of these. So this will be 2x minus x squared plus 5x minus 5x becomes a plus. Distributing the negative sign some more, plus 4x minus 20. Again, the denominator hasn't changed, and in fact, I don't know if it ever will. Can combine like terms. I only have one term with an x squared in it. I have 2x, 5x, and 4x. So this adds up to 11x. And the negative 20 at the end. So, what I'm going to do here, which is certainly not necessary, but I like to personally do it, I like to make sure that the first term out here has a positive coefficient. So I'm going to pull out a negative 1. Again, this is not necessary, but I like to think about things like this. And by pulling out that negative sign, I have to pull a negative sign out of the 11x, which means that it'll be negative 11x. If I were to go backwards, negative 1 times negative 11 will give me positive 11, and pulling a negative sign out of the 20 gives me this. We are nearly done. We just need to check, can I factor the top anymore? So the question is, can I factor this expression? If I can, I'll need to pull it apart. So what I notice is that I've got my quadratic expression here. This is trinomial. So I've got an x squared. So if this were factorable, it would be x plus or minus something times x plus or minus something. And these two somethings will have to multiply together to get 20 and add together to get negative 11. So let's write down a little chart here. What numbers can I multiply together to get 20? I can multiply 1 times 20. I could multiply 2 times 10, or I could multiply 4 times 5, or have negative signs in front of all of them. So in fact, I want them to add up to a negative number, so I'm going to consider negative 1 and negative 20, negative 2, negative 10, negative 4, negative 5. And what do they add up to? Well, this will give me negative 21. Well, that's not negative 11, that doesn't work. This gives me negative 12, that doesn't work either. And this gives me negative 9. Well, that doesn't work either. So nothing works, which means this isn't factorable. And this expression is what's called irreducible. It's like a prime number in the sense that I can't factor it. It doesn't have any nice factors like this. So in fact, this is our final answer. This top, even though I've got this trinomial in here, x squared minus 11x plus 20, that doesn't factor. So we are done with this question, remembering that this is just subtracting two rational expressions. You can find yourself in a situation where you can find big polynomials that simply don't factor. The last part of this section is looking at complex rational expressions. So a rational expression is going to be a fraction where the numerator and denominator are both polynomials. A complex rational expression is where the numerator and denominator can contain their own rational expressions. So this is nested rational expressions. So, for example, this first fraction here, we have a numerator and denominator. So it looks like a fraction thus far, but we've got our own. Maybe you can highlight this in a different color. We've got our own rational expressions inside. The 1 over x is a rational expression. So ultimately, this is kind of like a rational expression, except it's got rational expressions on the inside. So therefore, it's a complex rational expression. The same way for this next one. The top is a polynomial, a very silly polynomial, it's just the number 2. The bottom is a couple of rational expressions. So we would approach these in pretty much the same way as we would anything. When we look at an expression like this, we can look at the top and we see that, okay, we've got 2 fractions that we are subtracting. In order to subtract these fractions, we need to have a common denominator. The only factor of x is x. The only factor of 2 is 2. So this is fairly straightforward. Oops. To get a factor of 2x on the bottom, I'll multiply the first fraction by 2 over 2. The second fraction, I need an x on the bottom, so I'll multiply by x over x. And we'll get 2 over 2x minus 3x over 2x. And then simplifying this, we have 2 minus 3x over 2x. So this is going to be the numerator. This is the numerator. Let's look at the denominator now. We've got 1 over x plus 3/4. Again, we'll go through the same thing. The only factor of x is x. 4 will have a factor of 2 and of 4, but the common denominator is going to be x times 4, since the x doesn't have any factors of 4 in it. So 1 over x times 4 over 4 plus 3/4. And again, we need that factor of x on the bottom, so we'll just multiply the top and the bottom by x, and we'll have 4 over 4x plus 3x over 4x. Now I can add these guys together since they have the same common denominator. So 4 plus 3x over 4x. Here's where the fun starts. Let me copy my fraction down again. 1 over x minus 3/2 over 1 over x plus 3/4. And now I've simplified the numerator and the denominator. So the numerator is just 2 minus 3x over 2x. The denominator is I should use my simplified version. So this is going to be 4 plus 3x over 4x. And just like always, I'm taking a fraction and I'm dividing it by another fraction. Therefore, it's the same as taking the top fraction and multiplying it by the reciprocal of the bottom fraction. 4 plus 3x. Okay, we will look for, so in order to multiply fractions, we factor each part of both fractions. The nice thing is that these are almost factored completely. The one thing to notice is that the top of this fraction, 4x, I can write this as 2 times 2x. And the reason I would do that is because now I've got a 2x and a 2x, which I can cancel. So, continuing on, after I cancel the 2x off the top and the bottom, what I'm left with is a 2 minus 3x, and I'm left with just a 2 on that side. Down here, I have a 4 plus 3x, since the other side is canceled. And in fact, this is as simple as we can make it. I'm going to rearrange this so that it looks nicer though. First of all, I like to put the numbers out front. And I like to put the terms with x in decreasing order. So I'll write the negative 3x plus 2. This is certainly not necessary, and I'm only doing this because I think it looks a little bit nicer and easier to read. So then I'll put the 3x down front. And again, I like my terms with an x in the front of a polynomial to be positive. So I am, in fact, going to pull out the negative sign and rewrite this as negative 2, 3x minus 2. Again, if I distribute the negative sign, I get right back to what I was looking at, and 3x plus 4. This is as simple as I can make it and as nice to read. This works, but so does this. This is also simplified. And I will stop there.